So, okay, I know that you're going to present yourself in the presentation, so I'm not taking much of anyone's time. As always, everyone can ask questions here in the chat. I'll be following it, and I'll be back after the presentation. So, for now, Randy, the stage is yours. Let's hear from you.
Great, thank you. Hi, everybody. I'm Randy Shoup, and I want to talk today about improving software flow. So a little bit about my background. So I'm currently chief architect at eBay. I spent a bunch of earlier years of my career at eBay as well. I spent some time as an engineering leader at Google, also a VP of engineering at Stitch Fix and at WeWork. And so a bunch of these, experiences are going to color a bunch of the stuff we're going to talk about today. So in terms of improving software flow, I want to break it up into 5 areas. And these 5 ideals are some great ideas that came from one of my favorite new books called The Unicorn Project, written by my friend Gene Kim. That his name will be familiar to any of you who have read The Phoenix Project or Accelerate or any of those books. And he identifies 5 ideals for how we can do better software. And so first, we're going to talk about locality and simplicity. Next, we're going to talk about focus, flow, and joy. Third, we're going to talk about the improvement of daily work. Then we're going to talk about customer focus. So let's get started with locality and simplicity. And the idea here is that when we make changes to software, we want to make changes that are local and don't break things that are far away from what we're changing. And so this is a motivation behind all the major architectural evolutions of those large-scale companies that we all know and hopefully love. So eBay, depending on how you count, is on its 5th complete rewrite of its infrastructure. So it started as a monolithic Perl application almost exactly 25 years ago. It became a monolithic C++ application with 3.4 million lines of code in a single DLL at its worst. Then it was broken up into smaller individual Java applications. You might call them mini applications instead of microservices. And then now it's fair to call eBay a polyglot set of microservices. Twitter has gone through a similar evolution. So Twitter's maybe on its 3rd generation. It started as the world's largest Ruby on Rails app, which they codenamed the monorail. Then they broke out a bunch of the front end into JavaScript, a bunch of the back end into services, mostly written in Scala. And now it's fair to call Twitter a polyglot set of microservices. Amazon has gone through a similar evolution. So it started as a monolithic front end in front of a monolithic back end, so a Perl and C hybrid. Then the next iteration, which took them basically the years 2000 to 2005, they rewrote that monolith into services, a lot written in Java and some written in C++. And now it's fair to characterize them as a polyglot set of microservices. And the why behind all of this is because as companies get larger, they want to keep moving quickly. And if in a monolith, changes have lots of cascading effects all over the place. So what it looks like at large scale is actually not one big team building a monolith, but a bunch of small teams. And so having an architecture that allows those small teams to build individual components and services separate from each other allows them to continue to iterate quickly and move quickly. And so you want there to be this duality between a modular architecture and a modular organization. So typically you'll have one domain or one team, and which is going to manage one or a small number of services. And we want, as Mel Conway would say in Conway's Law, the idea that organization and architecture should be reflections of each other. And this allows the individual teams to have autonomy to independently design, develop, and deploy their services separately. And also it allows the teams to own those services end to end to quickly iterate. From a architecture perspective, this modularity obviously allows us to abstract and encapsulate parts of the system from other parts. So it allows us to isolate faults to one particular area. Again, that's a core idea of locality and simplicity, that we want issues to be local to the team so we can fix them locally rather than having large scale effects farther away. It also obviously allows us to choose separate technology stacks if we need to for particular services versus others. It allows us further to do performance optimizations and allows it to be a security boundary. But all of these ideas, these are all benefits of this idea of locality and simplicity. The other thing, of course, is that we want to make sure that the area around the interface around that component is really solid. And so one of the best practices, of course, is that we specify very concretely an interface contract that allows us to specify clearly how individual components are going to interact with the outside world. And as we iterate on it, we want to make sure that those iterations are continue to be backward compatible so that other dependencies of ours don't get broken. And it also allows us to test and mock locally. And then over time, what you'll find is you'll start with one team, and then it'll split into two, and maybe they will split into two, and so on. And so this is like secondary school biology, cellular mitosis, where we start with one cell, which divides into two daughter cells, which in turn divide into two daughter cells, et cetera. The related idea here is just like we want to encapsulate functionality, we also want to encapsulate change. And so events are a great way of doing that. So events allow us to decouple the domains and teams from each other, allows us to abstract that idea of the change, and allows changes that in one area to be asynchronously communicated to the other area. So it allows us to decouple the services that cause the change from the services that are consuming or reacting to the change downstream. And again, just like with the services, we want to make sure that we have a formal interface around the events that we use, which again allows us to test and mock out those different kinds of changes that we see, and allows us to be forward and backward compatible. And from a team organization perspective as a leader, my sort of rule of thumb is I want to make sure that 80% of a team's project work can happen within the team boundary, and maybe only 20% is needing to coordinate very deeply and very in a highly coupled way with other teams. So we talked about locality and simplicity. Now let's talk about focus, flow, and joy. What do we mean by focus, flow, and joy? That sounds kind of funny. Well, I'll quote one of my favorite personal heroes, Richard Feynman, who's Nobel Prize winner in physics. So he likes to say, if you're not having fun, you're not learning, and that there's a deep pleasure in finding things out. I hope that's everybody's experience of being an engineer. I know it is. I know it's mine, where one of the things I love about being an engineer is learning new things, and there's just a deep pleasure in that. But the idea of focus has a psychological underpinnings, and there's actually physiology that's associated with our ability to focus on a particular thing. So psychologist Daniel Goldman back in 2013 wrote this great book called The Focus, the Hidden Driver of Excellence. And what he noted is that individuals' ability to focus, what he called their cognitive control, is actually the best predictor of individual success and individual high achievement. And as I was saying, as he notes, focus that actually has a physiological component. So focus is the ability to moderate or couple together the top-down higher brain called the neocortex or the prefrontal cortex, which is about executive function and about the places where we do reasoning and reflection and self-awareness. But coupling that with the bottom-up lower brain of the amygdala, which is one of the oldest parts of the mammalian brain, which is where we have emotion and motivation and passion and impulse. And focus is the ability to use the passion that we get from the amygdala and moderate it with the higher brain. I just find that really interesting. So as an individual, what can we do to improve our focus? Well, one of the best things that we can do as an individual is practice some kind of mindfulness or meditation. And so one of the great things that he notes in this book is that from the perspective of cognitive science, all the kinds of meditation practices that we might have are methods that actually help us train our attention. So now let's move to what does focus, flow, and joy mean in the workplace? So Mihai Csikszentmihalyi, one of the great philosophers and psychologists of modern times, wrote another great book on flow, and he spent his whole multi-decade career studying how people that are high performing get into and maintain their flow states. And so one of the things that he notes in this wonderful TED Talk is that the flow state that, all of us have experienced at one or another times in our life, where we're just completely immersed in a particular task that we're doing and everything else kind of falls away. What are the characteristics of that? So the characteristics are when we have a balance between the work challenge that we have and the skills that we bring to the task. We're getting immediate feedback from the code that we're writing, or the poem that we're writing, or the music that we're playing, and it feels effortless. It feels easy, but we also feel in control. And so we want to make sure, we want to see how can we do this in our daily lives, and how can that will allow us to be happier and more effective. So one of the best ways to do that is by managing our time. So Paul Graham, the founder of Y Combinator, wrote this wonderful blog post back in 2003 called Maker's Schedule, Manager's Schedule. So the idea is that a maker, a knowledge worker like all of us, well, most of you, engineers, product managers, people that are actually doers, this is your ideal schedule. So maybe you'll have a meeting in the morning, you'll have a whole bunch of, multiple hours of uninterrupted work. You might have a meeting in the middle of the day and then a whole bunch of hours of uninterrupted work. When we don't have this, we're not able to get and achieve flow. By contrast, though, the manager schedule, and this is the hat that I'm wearing in the last long while, we're playing calendar Tetris with like half-hour meetings, meeting. And so the problem comes when those two schedules conflict. And so as a manager, the best thing that I can do for the individual contributors that work for me is not schedule meetings like right in the middle of their flow time, right? So if I schedule a meeting with somebody at 10:30 or 11 in the morning, that's like right in the middle of their work time. It doesn't matter to me whether I'm meeting with them at 10:30 or 2:30 or 1:30 because my calendar is a big mess. But it does matter to them. And so something that we can do, something that you can do as makers, is try to block off that time in the middle of the day and see if you can reject those meetings. And the thing that I can do as a manager, as a leader, is not schedule those meetings in the middle of your work. Another great book that talks about this particular idea is called Making Work Visible by Dominica de Grandis. And so again, what can we do as individuals to protect our flow time? We can try to make sure that we do meetings at like breaks in the day, right? Like as I was showing before, where try to do meetings at the beginning of the day, the end of the day, or maybe around your lunchtime. Heavily use do not disturb on Slack or whatever chat system that you're using in your company. Feel free, make it okay within your team to, I'm going to go away and actually do some work for an hour or two. Consciously manage interrupts that are happening, and then also the more that we can automate away a bunch of those interrupts. And I don't really mean meetings, but I do mean things like tickets and things that we can do to improve the system so developers don't get taken out of their flow time. So the other key idea here in terms of focus, flow, and joy is more that focus part. So as Steve Jobs liked to say, don't try to do everything, do one thing well. Or the way that I like to say this is do fewer things, but get more done. So from a team perspective, a lot of times we organize ourselves in this way. So we have a bunch of individuals on our team, and each person is working in parallel on something entirely separate, but that it takes a long time for us to actually finish those things. It's much better if we, assuming that we want to get feature 1 and 2 done earlier, have instead of one person working on it, have 2 people working on it instead. And so get those things done earlier. So this is from a team perspective, focusing on a smaller number of units of work at the same time, but getting them done earlier. So if we think from a lean management perspective, this is called managing work in progress, right? Limiting the work in progress. Instead of doing 5 things in parallel, let's do 3. And oh, by the way, we can get even better if we apply the idea of doing things in incremental units. So instead of working for 2 months on something and releasing only something and getting feedback in the end, what if we instead along the way released incremental units of work and got incremental feedback, which would allow us to potentially change direction, which would allow us to learn a lot faster than if we went all the way to the end. And by the way, this also gives us joy as developers. One of the reasons why we like to do these jobs is because we get that immediate feedback by doing our work. It passes the tests. We get it out to customers, and we get some good feedback, hopefully, about the work that we did. But the other important notion is that this protects against other context switches that we have. So I'm sure we've all had the experience of we work really hard on something where 3/4 done or 90% of the way done, and then there's some higher level, boss who tells us we have to change our priorities, and we end up abandoning all that old work. Well, the problem is that only becomes a problem if we haven't released incremental units of work along the way, right? If we've queued up 4 months of work and we stop after 3.5 months, that's a real problem, and we've wasted that whole 3.5 months. But if instead we'd been releasing, every week or every couple of weeks along the way, even if we had to abandon anything, it would be just a little bit at the end. So all these things have a lot of impact on our ability individually and as a team to focus and stay in flow. I'll just end this section with a wonderful quote from Einstein. It's not that I'm so smart, it's just that I stay with problems longer. Okay, so we talked about locality and simplicity. We talked about focus, flow, and joy. And now I want to spend some time talking about the improvement of daily work. So W. Edwards Deming is probably best known in the lean area as the early on in the 20th century, an inventor of all these things that we now call lean manufacturing. And Toyota, which has probably taken lean manufacturing to its highest level and has been doing so for several decades, ultimately learned these techniques from Deming after World War II. So in terms of improving daily work, a lot of us, one of the reasons why we became engineers in the first place is that we want to make the world a better place. And we want to make the broader world a better place, but we also want to make our little micro part of the world a better place as well. So we really want to make improvements. And the challenge is when the system doesn't let us, essentially, when we don't give ourselves overall the time to make improvements. And so I just want to kind of appeal to empathetically to everybody that it doesn't matter how good you are if the system is bad, But let's talk about how we can make the system better and let that goodness of the people shine. So a lot of us have experienced this, and maybe we're currently experiencing it. So we're in this cycle as a team of technical debt where we do something quick and dirty, we accumulate a bunch of technical debt. So now when we go around and try to do the next thing, we don't have time to do it right. And so we do the next thing quick and dirty, we accumulate more technical debt, it makes it even harder to fix it. And we're in this vicious cycle of going round and round. And where we want to get to, and what we'll talk about in this section, is we want to get from that vicious cycle of technical debt over to a more virtuous cycle of making investments in improving the quality of our software, but also improving just our practices of doing daily work. So we want to make investments in quality and small investments in our improvement, which gives us a better, more solid foundation on which to build the software. That gives us more confidence, which allows us to move faster, which frees up more resources and time to do more investments in quality, gives us a more solid foundation, and we're going round and round in this virtuous cycle. And so one of the things that I've found as an engineering leader, that's a way of getting out of these technical debt spirals, is something that I like to call an improvement budget. So what I will often do as an engineering leader is I'll go to my peers or my bosses, the people that control the resources. I'll say, hey, here's all the problems that we're experiencing around the technical debt, which I'll enumerate in ways that they'll understand. And rather than having a discussion about each individual piece of improvement that I and my team would like to make, what if we overall just set aside a budget, let's call it 20%, 25, 30%, something like that, of a budget of our time and resources that we're going to spend on improving things, whether making the build better, reducing technical debt, et cetera. So we agree upfront on a particular, a level of investment that we're willing to make, and then the key thing, which has worked well for me as a leader, is rather than litigating and discussing each of those individual things with my other mostly non-technical peers, instead I'll say, look, give us this budget. We'll be completely transparent and tell you exactly what we're doing with the budget, but we're going to figure out what to do and where to apply those resources. So the way I like to think about that is have the engineering team, retain the autonomy to figure out which detailed investments to make as part of this budget, and then obviously always provide transparency back to the product and business partners that we're working with. And the point that often, when sometimes I've had, well, I need you to need you to tell me all the individual things, and we need to discuss them. And one of the points that I've made more than once in my career is that making these kinds of investment decisions and trying to figure out which areas to improve the software, that's exactly why you hired me. So I've definitely said that more than once as an engineering leader. Cool. Gene Kim, again, the author of that favorite book, Unicorn Project, likes to say this, and this is a bit counterintuitive, but stay with me. Improving daily work is even more important than doing daily work. You're like, what? The reason why I do the job is daily work. Well, but if we put 1 unit of effort into building a new feature, we're going to get 1 unit of benefit out of it. But if we spend that unit on making the overall practice of our system better, maybe we'll be able to get next time 1.1 units or 1.5 units or even 2 units. Often, and this has been true for decades at Toyota, often investing in improving daily work is the best way for us to bend the curve and make things better, and actually ultimately end up producing more features and better outcomes for the business. So one of the things that comes directly out of Toyota is something that's called the improvement kata. So a kata is a martial arts practice about improving your capabilities. So the idea is understand the direction that you want to go. So what goal do we want to achieve? Understand where we are, grasp the current condition, establish the next near-term target about what we're going to do, and then move iteratively toward that target. And the way to move iteratively toward that next target, back to Edwards Deming that I mentioned a couple of minutes ago, is something that people have now called the Deming Cycle, which is plan, do, check, act. So I feel like I should explain those a little bit because the words aren't perfect. Plan is think about one small incremental improvement we can make. Do is do an experiment to see if it actually achieves the goal that you think it's going to achieve. Check to see if the experiment worked. In other words, if the thing that you did actually improved the build or something like that, then if it did, great, act and put that into practice more broadly. If not, try to plan another improvement. So just keep iterating small steps, small steps, small steps, and ultimately we're going to get a big payoff. I know there are a bunch of engineers already that are saying, hey, my product and business partners won't let us do all that kind of stuff. Well, here are 5 words that I found super powerful in all these situations. Let's just try an experiment. So next time you're in a situation where you feel like you could do something that would really make the developers' lives easier or the customers' lives easier, and you're having difficulty maybe convincing other people, just try this. Let's just try an experiment and see if it works. Great. Okay, so now I want to talk about psychological safety. So as people have probably, hopefully people have been hearing over the last couple of years, what we've been learning about high-performing teams and high-performing organizations is that psychological safety is one of the most important aspects of teams that to do well. So Google, being Google, studied themselves and spent several years doing what they called Project Aristotle, where they tried to figure out why were certain teams better performing than other teams? And you can imagine that they had a bunch of hypotheses like, oh, well, it's the team that has the most PhDs. It's the team that has the most experience at Google. It's the team that has the most experience at in the industry overall. It's more mathematicians. Who knows? You can imagine they had all of those technical, hypotheses. It turned out none of those mattered at all. Instead, what mattered was psychological safety, which is the team is safe for interpersonal risk-taking. What do we mean? It means that in a team, everybody feels that they're able to sort of bring their whole self to work without fear of negative consequences. And when I say bring their whole self, I'm going to talk about 2 aspects. I'm going to talk about the diversity and inclusion aspect, where we're going to form teams out of diverse individuals and actually listen to them and ultimately get better decisions. And then also I'm going to talk about fear, where people fear to do risky things because they might be sort of punished or fired or humiliated if there's an outage or something like that. So both these aspects are critical to psychological safety and giving everybody the ability to show up. And again, at Google, this was more important than any other factor in team success. And the intuition here is that if everybody is able to show up and bring their whole self to work, that means they're not, first off, they're not spending 25 or 50% of their brain, worried about whether they're going to be made to feel bad by their colleagues. But it means that they can give 100% to all the new, 100% of their brain power to new ideas and creative ways of improving daily work or making lives better for customers. So the idea is, how can we spend all of our focus and attention on making the situation in the team better? So in terms of the diversity and inclusion angle, so there's been a lot of studies recently that show that diverse teams, inclusive teams, actually make measurably better decisions. And incrementally, as we improve the diversity of our team, every increment of improving of diversity, we improve decision making. So fully diverse teams, which include gender diversity, age diversity, and geographic diversity around the world, make better business decisions 87% of the time. When we do it with just one gender, it's 58% over an individual. When we add gender diversity to that, I think it becomes something like 63 or 73%. But when we do the full aspect of inclusion and diversity, again, gender, geography, and age, obviously there are other aspects as well, but the study showed that would make better decisions 87% of the time over an individual. They also, by the way, make decisions twice as fast with half the meetings, and they deliver 60% business results. So it's not, I mean, as humans, we should be kind to other people and we should be inclusive of them in our teams and in our lives. But it also turns out that if the only thing you care about is business results, it's also good for business to do that. Great. Okay, and then the insight here is this comes from Bob Taylor, who ran a very famous research lab in the United States called the Xerox Palo Alto Research Center, and he brought together a bunch of diverse people to build, the first personal computer and object-oriented programming and Ethernet and the graphical user interface, and he liked to say, none of us is as smart as all of us. So that was sort of the diversity and inclusiveness angle of psychological safety. Now I want to talk about the fear part. So I've been very lucky to be part of this kind of global DevOps community where we're all learning together about how to build better software and better teams and so on. And I was very fortunate to be part of working together on a white paper a couple of months ago on how to attack incident response. And so one of the things that we didn't invent, but we wrote up in this white paper is this idea that I hope people are practicing, which is called Blameless Postmortems. So the idea is that when something bad happens, so when there's a customer impacting event, our system goes down or something like that, that we have an open and honest discussion with the people involved about what contributed to the incident, what did we do well, and then what could we have done better. And the idea is we're not looking for people to blame or to fire. We're looking for ways that we can learn to get better next time. And we want to take a real systems thinking approach. So we want to look at, well, how could we have detected the incident earlier? How could we have diagnosed it faster? How could we have mitigated it? How could we have remediated it more quickly? And maybe how could we have prevented it from happening in the first place? And if we make this psychologically safe, in my experience over and over again, what I found is that engineers almost compete to take responsibility. And I'll give a specific example from Google there in a moment. But the place in the engineer's heart that this comes from, why would everybody want to be tripping over themselves to say, oh, well, it was our team that, contributed to the incident? It's this place in the engineer's heart. And I bet that all of us can, sympathize and empathize with this feeling, is that, okay, I feel sad that we had this customer impacting thing, but finally we're going to be able to prioritize fixing that system that I've been saying has been broken for so long. I'm sure we've all had that experience as engineers. So I want to give an example from Google App Engine. So that's Google's platform as a service, and I was the engineering leader there a couple of years ago. So the details here aren't super important, but we had a global outage in October 2012, which was probably one of the worst days of my professional life, all the multiple decades of it. So 4 a.m. Pacific time, a load started increasing on the incoming traffic and one of our data centers. The SRE, the ops set of people did their standard playbook, started to globally restart everything. We kept playing our individual playbook. It was not working. We discovered after 7 hours, 8 hours of work that we were in a cascading failure. And then the only option we had was to fully restart everything about App Engine globally. And so, Snapchat was down. The predecessor to Pokemon Go was down. 3 million applications around the world have been down for 8 hours. So this was a pretty grim day. And afterward, of course, we wrote up a public postmortem, and the link is here in the slides when those are shared, if you ever want to look at it. So obviously, we increased the capacity for that. Okay, that was an easy thing to do. But the most important thing was that we started up multiple projects, which then went on for the next 6 to 12 months to figure out how we could do better. And so that's the story that I want to tell here around psychological safety. So we called it the reliability Fixit, but it was basically a blameless postmortem on steroids. So the first thing that we did is we got all the senior engineers and leads in a room from all the different teams that were involved and peppered, this was in the day where we met physically. So we peppered the whiteboards, filled the whiteboards in the room with everybody's ideas and brainstormings about issues that we might have had and potential solutions to them. And we ended up consolidating them into a couple of different themes. Then we grouped those themes. We assigned each one of them to one individual to go and think about it further. And we time boxed that further, research and thinking to a week. And we wanted to make sure that even though we got all the brainstorms out in the meeting, we wanted to make sure that there weren't things that we were missing, and we wanted to kind of think more carefully about stuff before we leapt right in. So we had those individual engineers go and look at all those individual themes. Then we did a consensus and prioritization situation where we discussed those themes, we prioritized our work, then we got to work and started implementing it over the next 6 to 12 months. And one of the things I'll say is that the results were amazing. So first off, we reduced the reliability issues a lot, which was our mainline goal. But the thing that we remember still 8 years later is how much we got the team cohesion and camaraderie, and it really turned everybody in the team around. So it's something that when I get together with my friends there, they still remember even 8 years later. So psychological safety really, really matters. So the last ideal I want to talk about is customer focus. So the best way I can think to frame this as an engineering leader is we want to make sure that we're looking for outcomes, not outputs. What do I mean? I mean that we want to, as engineering leaders, understand the business outcomes that we're trying to drive. So we want to make sure that we understand that, okay, what we're trying to do in our business is we have this goal to grow revenue or improve our profitability or improve our market share or reduce customer churn, something like that. And it's important, even though our day-to-day job is writing code, it's important for us to understand what that code is intending to do for the business. And at the same time, we want to make sure that we understand clear customer metrics. We want to make sure that we understand the performance of those key customer flows. So at eBay, that would be somebody going through and listing an item on the site, a buyer going through and buying or bidding on an item. We really understand the customer flows that people are, what they're trying to achieve, and are they able to achieve it. And then some of the techniques that we use at eBay is that we talk about failed customer interactions. So these might actually not be these might not be failures of engineering systems, but they might be that the customer wasn't able to achieve the thing that she was trying to achieve. We're actually tracking that at a high level in the business to make sure that those things are working well. And then we also track something that we call availability to the business, which is when we have a customer impacting event or a site outage, we measure the impact of that outage in terms of the overall business outcome. So we measure its impact, directly measure its impact to revenue and to those customer interactions. And that's a great way to help to communicate to our business partners what the impact of things are, why we should make investments or not in improving the underlying characteristics there. But it also helps us to prioritize those things as well. And the way that I found as an engineering leader, to communicate these ideas with my product and business partners is to speak their language. So going and saying, I want to make the code more elegant, that is not a very convincing argument. And I'll find, even as an engineer at heart myself, I don't find that argument convincing as well, either at this moment. That's not itself a goal. What is a goal is improving our ability to get things done in terms of time, improving our efficiency in terms of people. Does it take us 10 people to do something or one? And improving our ability to make or retain money. So using these common currencies, that allows us to communicate effectively with our business partners, but also trade things off in a principled way. Should we invest in doing this feature that's going to drive more revenue, or should we invest in this feature that's going to reduce our technical debt and potentially reduce risks to time and money and people? So the other thing that I think is a critical tool in our engineering toolbox is always asking what problem we're trying to solve, and always frame the thing that we're doing in terms of focusing on what the customer is trying to achieve and how we're helping her achieve it. So when we have those conversations with our business partners, one of the things that I've said many times is that the unique thing that we bring to that conversation as engineers is this thing that we have trained ourselves to do around disciplined problem solving. And, a bunch of us have had training in other disciplines. I actually have a degree in political science for whatever reason. And, I learned a lot of other stuff in gaining my political science degree, but I definitely didn't learn disciplined problem solving. That's a thing that I've learned, through the engineering part of my education and my career. And that doesn't mean like one set of people is good and another set of people is bad, but the unique thing that we as engineers can bring to those conversations is clearly clarifying the problem, breaking it down into smaller chunks, and iterating on it. And by the way, this is our job in those conversations. Our job is to help clarify and refine the problem for our business and product partners, and help them understand what it is that we can do about it. So the other notion is that we really always want to stay focused on the customer problem. And while I and my team love to write code, that's not always the solution to the problem. The way I should frame my job, and you should frame yours, is understanding customer problems and it's solving them. And only sometimes do we solve those problems by writing code. So when I was the engineering leader at Stitch Fix, so Stitch Fix is a clothing retailer with a bunch of physical warehouses, one of my teams built software for those physical warehouses. And we would go and work with the teams there. And oftentimes they would say, hey, can you change your software to make it so it's easier to do X or Y or Z on the assembly line? And oftentimes by asking what problem are we trying to solve, and really understanding the problem, many times we came away collaboratively with a decision, let's leave the software alone, but let's actually reorder some of the steps along the assembly line, because that's actually the most efficient way to solve the problem. And that was a win. Right? So even though we didn't write a line of code, we still solved the customer problem. And that's, I think, the important ethos for us to have, both as engineers and as engineering leaders. So we talked today about locality and simplicity. We talked about focus, flow, and joy. We talked about the improvement of our daily work. We talked about psychological safety, and we talked about customer focus. So I want to leave you with a few thoughts. So if you haven't read this book, Accelerate, I strongly encourage you to read it. By the way, Gene Kim also is one of the co-authors. But by following these 5 ideals, as you'll learn in this book, companies and organizations are actually 2.5 times more likely to exceed their business goals in terms of profitability and market share and productivity. So all this stuff doesn't just matter to engineers, it also matters to the business and to customers. And the other thing I'll leave you with is a wonderfully sarcastic comment by my friend Martin Fowler. So if you don't see these characteristics in the organization that you're working, well, first, you absolutely should try to change your organization, try to share these ideas, and try to make improvements at your own level. But if you can't change your organization, as Martin likes to say, you can change your organization. So thank you very much. Now I think we might have some time for questions.
Yeah, Lucas has a question. So what are the main questions that you would ask if a requester would come and say, we need to change? I would just change the project.
Yeah, I'm not sure I fully understand it, but if the question is, if somebody comes and says we need to change the direction of the project, I mean,
yes.
You can always apply the what problem we're trying to solve question. Like that one is universally applicable. So a lot of times, people will come with solutions, or hey, we need to do this other, this thing or this other thing, and just for your own knowledge, help ask the questions to try to see why that is. It's not a challenge. It's not I disagree with you. It's that I don't yet understand where you're coming from. And again, that's where the engineering problem solving comes. A lot of times, it's a different example, but a lot of times people, I've had product people come and say, hey, can you just add this button to the app? Just add this button. I'm like, well, why? Help me understand the customer problem. And then a lot of times we'll have a conversation and it turns out, okay, well, maybe we already have that functionality somewhere else, or there's an easier way to achieve the customer goal than adding this button, or it has some downstream effects that the product person didn't and couldn't anticipate because he or she's not in the code.
Yeah, so Lucas is asking what besides that question, even though I think the why question, it's hard to tell without the specific situation, right?
So start with why always. I think we need to understand a little bit more of the detail, unfortunately, of that particular thing for me to be more tangible or more satisfying in the answer. But let's break it down. So, okay, we're stopping doing this thing and we're starting doing this other thing. Well, think about, let's talk about what the benefits are of the new thing. Let's talk about what the benefits are of the old thing. You can also offer, if we're in this case where like you're 80% or 90% of the way there, you can make that clear. Well, you know what, like with another week or two of work, we can actually get this thing done. Really what we're doing in that conversation is not peppering them with questions as much as understanding their context. What do they understand that we don't? But then also offering our context. What do we understand that they don't? And by the way, that's a lot. And most of us engineers are, we're dial more on the introverted side of the spectrum. And, maybe these conversations aren't things that we naturally want to do, but it's a good practice to just say, yeah, here are the things you might not be aware of. Like, again, we're so close on this other thing. The new thing that you're suggesting has a lot of potential impact to technical debt, which again, why would you know that? But I can tell you about it. Like, that's our part of the conversation, is providing facts, and we together make a collaborative decision.
Yeah. Thank you. And we have more. Thank you, Lucas, for the question. And we have more questions, and questions are very much appreciated. So don't be shy. So Pavel is asking, does blameless approach to incidents applies to small teams? Example, 2 engineers.
Yeah, sure. Look, with 2 engineers, I hope there's a lot of trust between the 2 of you. If there's not, that's a real problem. But with a small team, it's really easy to develop the level of trust. So, am I telling you that you have to go through a formal process after something happens? No, I'm not telling you that. But what I will say is the attitude of, hey, I just broke the build, or I just shipped something that took us down for a couple of minutes. Like, don't blame the other person. Don't make that other person feel bad. It's like, oh, well, sorry that happened, and what could we do better next time? The concept, the attitude, the concept behind the blameless postmortem is applicable regardless of the size of thing. And again, people probably know this, but the idea of blameless postmortems is not unique to engineering at all. Like every industry that cares about safety, whether it's healthcare, firefighting, the military, transportation safety, every one of these industries has like independently discovered this idea that you really want to make it about learning and not about blaming the individual.
Yeah. I wonder if I'm the only one who feels like I wish my boss could see this talk. Not me only. So I get this feeling that I'm not the only one talking about blaming and so on. And we have more questions from Pavel, from Ginteras, and he's supported by others who say that's a very important question. Why in modern coding schools they teach to code but not to engineer, and how to begin to teach about engineering?
Yeah, I think it's different. I think it's different at the different. I will say a bunch of the so-called boot camps, the coding schools are really good at teaching test-driven development. Like they start that from the very beginning. And so I've been extremely impressed at several organizations that I've led, bringing graduates of these boot camps on, again because they don't come with the same level of like maybe algorithmic experience as people who with a 4-year university degree, but their ability to learn is like hugely fast, and they come with the practices of test-driven development. So yeah, so you asked the question, why do we learn coding and not engineering? I mean, I think that's a real opportunity, right? Because the other so-called engineering disciplines, structural engineering and civil engineering and mechanical engineering, they are learning that stuff. So I mean, I think we definitely have a ways to go in terms of our industry to level that up. But and there are definitely university programs that do that. But I just wanted to call out that like even the non-university programs have a really strong focus on, again, what I'll call the practices of software development, which I think is really valuable.
Great. One more question about team diversity from Ernestus.
Yeah.
How to solve all male, all same team? How to solve all male, all same age teams? Should they be reorganized?
Yeah, I mean, I think everything's a trade-off, but what I will say is all male, all same age teams are not going to make as good, they're going to make poorer decisions by the science than if you added more gender diversity, more age diversity, more geographic diversity. I'm not going to tell you you're wrong to do that, but there's other reasons to reorg or not reorg, but the science is it's really stark, and it's not just like a little bit better decisions, it's a lot better decisions. And again, all of you all that are all the same age and gender, like you all think really similarly, and like that's probably why you're friends. But the interesting thing is, like, the team, when you're making decisions, you actually want people with different perspectives. We need to respect each other, but the wonderful thing is, like, when you're bringing people in that come from different places, conceptually, that's where you get the real unlock, right? 5 people all saying the same thing isn't as good as 5 people respectfully and collaboratively offering 5 different sets of ideas, and then we come up with a much better solution.